Hey, ladies and gentlemen, I'm Erisa Wante, your online mathematics teacher. We are looking at discrete random variables, and we are now 2 lessons down the road. Today, this is going to be our 3rd lesson, and we want to talk about expectation of a discrete random variable. So what is expectation? Remember, a discrete random variable is denoted by a capital letter, but since X has always been the easiest letter for mathematicians to use, we are also using X, capital X, to stand for any discrete random variable. So what is the expectation of a discrete random variable? It is E of X, okay? So we have E of X is read as E of X, and it gives the average or typical value of X, known as the expected value. So that expected value, you can also call it expectation. Okay, so instead of saying expected value, we can just say expectation of X. So how do we find expected value of X? This is the formula. E of X is the summation, okay, of all X's. X times the probability of capital X is equal to small x. That means that you get the value a random variable takes and multiply by their respective probabilities. There you get what we call the expectation. Okay, so we can also write this. This can also be written E of X is the summation of the X size times pi's, okay, for I is equal to 1, 2, up to n, okay, and we use the symbol mu, okay. If you want, okay, let me write for you. Pronounced mu. It is a Greek letter. Is often used for expectation. Okay, we always use mu for expectation. Okay, where mu is the same as E of X. Okay, so you'll find mu sometimes used for expectation, but you have to know that how do we get expectation? We multiply the values the random variable assumes by their corresponding probabilities. That is it, and then sum. All right, this is a super easy example. The question is very simple. It is direct. They want you to find E of X, the expectation of X. So let's write the formula. How do you get expectation? Solution. We know that E of X is the summation X times the probability, okay, X is equal to small x, for all X values. So what are the probabilities here? The values of X, we have 0 times the corresponding probability, 1 over 6, plus 1 times the corresponding probability, 1 over 12, plus 2 times 1 over 4, plus 3 times 1 over 3, plus 4 times 1 over 4. Okay, No, this 1 over 6 rather. 4 times 1 over 6. So what do we get? This is 0 plus 1 over 12 plus 1 out of 2 plus a 1, then plus a 4 out of 6. So the rest is just mathematics, mathematical maneuvers. Do the mathematics, get the answer. But what you have to know about expectation, it is going to be an x value between 0 and 4. The expectation cannot be less than 0 in this case and more than 4. No, expectation is an x value. So the answer must lie within, okay, 0 to 4. So you do the addition. What's 1 over 12 plus a half, okay, plus, yeah, do the math. So the expectation is 2.25, okay? It is between these two. 2.25 is a value between 2 and 3. So the expectation in this case is 2.25, and we are done, okay? Maybe it may not be clear. Let me write it here. It is 2.25. That's the expectation. Here, students, before we go deep into the discussion of probability distributions and expectations, there is something that is really very important, and that is symmetrical probability distributions. Let's look at this example, okay? Let's plot a PDF of this example and see what it leads us to. Remember, we said yesterday that when you are plotting the PDF, you plot probabilities against the x values. So 1 has 0.1, okay? If you have to plot, this is simply 0.1. We go a vertical line from 1 up to 0.1. Then 2 has 0.2. Okay, so from 2 go a vertical line till we get to 0.2. 3 has 0.4. So 3 goes all the way up to 0.4. Okay, 4 comes back to 0.2. Okay, this is 0.2. Then 5 is the same as 1, which goes to 0.1. Okay, ladies and gentlemen, we have to be careful with this type of distributions. Okay, there is no special trick, but this distribution saves us a lot of time. If you plot a PDF and discover that there is symmetry about that a particular x value, okay, I'm repeating the statement. If you plot and discover that there is symmetry about a particular x value, then that x value becomes the mean or the expectation. Okay, in this case, you can see that 3 has the highest probability. Okay, let me write here, try to economize my space and see if I explain the point to you. Okay, but when you check clearly here, you discover that 3 has the highest probability, and the other values, okay, on either sides of 3 have same probabilities. The corresponding values, 2 corresponds to 4, and both have a probability of 0.2. 1 corresponds to 5, and they both have a probability of 0.1, because 3 divides these values into 2 equal parts. So we say that the distribution is symmetric about this value 3 here. Okay, reason is it has the highest probabilities, and it divides the values into 2 halves, and those 2 halves, the corresponding values have the same probabilities. Okay, so in this case, the expectation of x is gonna be just 3 without wasting time. Okay, the expectation is 3. Okay, but we can prove it. Let's check it and see. We can use our user formula of ex as the summation x times the probabilities for all x's. Okay, that means that 1 multiplied by 0.1 plus a 2 times 0.2 plus a 3 times 0.4, then plus a 5 times 0.1. If you multiply this and add, you end up with 3 as the answer. So if you are dealing with a PDF and you discover there is symmetry about a particular x value, that x value becomes the mean. It is not only the mean, but we shall discover that it is the mode and at the same time the median. Okay, it's the central value. Okay, so that is so important. Okay, it can save us a lot of time when we are solving questions about this distribution is. Okay, the point is clear, it is symmetry. There is also another type of symmetry, okay, where we have all of values having same probabilities. Let's see this other example. Look at this second problem. We are looking at x as random variable, the digit picked from a random number table. Okay, look at this number, these digits is 0, 1 up to 9. There are 10 of them. So if you pick a digit from there, the probability for each is going to be 0.1. That means that all the digits will have the same probability, 0.1. Okay, so let me put this in a table. And with this other type of distribution, why are we saying that this is a symmetrical distribution? So we have x, probability of x is equal to x, and we have 0, 1, 2, 3, 4, 5, 6, 7, 8, up to 9. This is the PDF we are coming up with. We are saying that each of these values has 0.1, 0.1, 0.1, 0.1, 0.1, 0.1, 0.1, 0.1, 0.1, 0.1. So if you go ahead and plot the PDF here, you have probability of x is equal to, okay, and here you have the x's. Then the probability is the same, 0.1 for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All of values will have the same probability as 0.1. Every x is going to be, vertical lines, 0.1, 0.1. Each value has the same probability, 0.1, 0.1, 0.1, 0.1. No, these are x's. So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So why are we saying that this is a symmetrical distribution? If we draw a line, because when I count, these are 1, 2, 3, 4, 5, 6, 7, 9, 10, okay? And if we look at the mean of these values, it is going to be 4.5. If we add all these values and divide by 10, then their mean is about 4.5. 1, 2, look, if we cross off this 1, 2, 3, 4, okay, and also this side 1, 2, 3, 4, then the mean is a value here which is 4.5. okay, so it is a symmetric distribution, and it is symmetric about 4.5. In that case, the expected value of x will be that value which is 4.5. If you want, you can prove this by calculating E of x, okay, will be equal to the summation of all x's, x times probability of, you discover that if you multiply 0 by 0.1 and then sum, you're gonna get 4.5. So in some cases, in some distributions, you may not really calculate the probability. You can look at a distribution and tell which value is the mean. So it makes your life very simple. Remember, we are looking at expectation, and expectation is the same thing as mean. Okay, we denote it by E of x, or we can represent it by mu. Ladies and gentlemen, okay, every time you have a random variable with the PDF probability of x equals small x is equal to a k, okay, the PDF is a constant for all the x values. That will be called a uniform discrete distribution. Okay, it is uniform because the probabilities are the same, and in that case the average value of the x values will always be the mean. Okay, so it is just simple. You can always deal with it so fast and tell which value is the mean. Okay, so this is important. I wanted to give it to you, but let's look at more examples. So examples about the mean of a discrete random variable. Having looked at its symmetric distributions, and then we can now go ahead and calculate the mean for other distributions which are not symmetric. Okay, using the formula we have looked at before. Look at this problem. We have been given information here, a table having x values and probabilities. The first question is simple. Find the value of y. Okay, how do we get the value of y? Since y is a probability, we know that the summation of all probabilities is 1. Okay, so that statement will give us y. Okay, so summation probability of x is equal to small x for all x's must give us 1. So what? Let's sum probabilities. 0.1 plus 0.3 plus y plus 0.2 plus 0.1 must give us 1. Okay, so what is y? Y will be 1 minus, that is 0.4, 0.6, 0.7, which is 0.3. So the value of y is 0.3. Next, how do we find the expectation of x? E of x equals to 1 into 0.1 plus 2 into 0.3 plus 3 into 0.3 plus 4 into 0.2, then plus 5 into 0.1. So we sum, we get the products and sum, then that will be the expectation. Ladies and gentlemen, the expectation is 2.9 and the value of y is 0.3. We are done. One more example maybe, or you can work out the other examples. It is really very simple. Lastly, let's look at this problem. My task, I'm going to draw a tree diagram, get the probabilities for you, and then you find the mean. Okay, so let's do this. There are 6 counters in the bag contains 5 black counters and 6 red counters. So in total we have 11. We shall use B for black. The probability of picking the first black is gonna be 5 out of 11. And the probability of picking the first red is 6 out of 11. So when you pick the first black and you are not putting back, then you can pick the second black, or you can pick the second red. Okay, the probability of picking a red, the black the second time, it will now reduces to 4 out of 10. This is 4 over 10. Okay, and you know, if you pick the first black and you're picking the second black, then the 6 red counters, you have not tampered with them, so this is 6 out of 10. Okay, or if you pick the first red and now you are picking the second black, this is black. Okay, then the black are still 5 out of the 10. Okay, or if you are chanced and you get the second as red, then these are now 5 out of 10. So picking black, this is the black one probability of B1, okay, intersection B2 is 5 over 11 times 4 over 10, okay, which we can write as 20 over 110. Then the probability of B1 intersection R2 is 5 over 11 times 6 over 10, which is 30 out of 110. The probability of R1 intersection B2, okay, is still the same, different arrangement, 6 over 11 times 5 over 10 equals to 30 out of 110. Then the probability of R1, okay, intersection R2 is gonna be, okay, that's 5, 6 over 11 times 5 over 10, which is also 30 out of 110. Okay, so we are using X to stand for number of red. Okay, so we can see that we can put X, then probability of X is equal to, so when we have two black, we don't have any red, that is 0x. The probability is 20 out of 110. Okay, if we have one red, it has two possibilities. You either pick black and then red, or you pick red and black. So when you add the probability, that sums to 60 out of 110. Okay, then we have these two black. Okay, this is 30 out of 110. If you want, you can reduce these probabilities, okay, to 2 over 11, 6 out of 11, and but it's gonna add up to 1. So this is a random variable. Now, the other thing you have to do is to find the expectation of X. That's the number, the actual number of ready counters. That's going to be 60 plus 60, about 120 over 110. So which is just 12 over 11, or one whole number and the 1 out of 11. That is, but take your time and do that. You know, this is still a simple lecture I'm giving. You know, it is about expectations. So in our next discussion, let's discuss about the expectation of any function of X. There are lots of examples I can give you, but nobody has tried to reach out to me about the trial question. Is if you inbox me, I will send you the trial questions and then you try it out. Okay, thank you, ladies and gentlemen, for listening to me. Let me hope you enjoy what I'm trying to do for you. Make sure you like, make sure you subscribe, and don't forget to click the notification bell. I wish you the best.